So this test is on chapter 4, 5, 6, and 7. Which sounds like a lot, but of course, most of those only have 2 sections. Chapter 4 has 3 sections, so it's not that many sections. Chapters 6 and 7 are almost the exact same problems, right? Can anyone tell me the one thing that chapter 7, bless you, that chapter 7 adds to the mix? Chapter 7 was all that crazy shit we talked about the last couple of classes. What's the only thing it adds to a problem? What is the newest thing we just talked about? Because that's chapter 7 is the last thing we talked about. What was the main thing from that chapter?
The normal bell curve.
Sure. That's chapter 6 is about the normal curve. Sure. Chapter 6 is the Z-score chart. Chapter 7. Sure. Chicken, lettuce, tomato. Central limit theorem, CLT. Right? And what the main thing, the CLT, the one thing that actually changes in a problem. Yes?
Sample by group, individual.
Sure. We're doing groups at a time instead of individual. Great. So what changes when I take a sample and I ask a question about the sample mean? What changes? So if I take, all right. So chapter 6 sets up the basic classical Z-score problem.
Because it's like X bar.
Huh?
You're saying like X bar.
Sure. Has something to do with the sample means, because we are taking samples. I like it. I like it. So chapter 6 sets up the standard kind of Z-score problem where they give us the sigma and they give me a mean. We make Z-scores, we look them up on the chart. We've done a ton of those problems, correct?
Standard.
Yes?
I don't know.
Okay.
I'm not wrong.
So this would be, this kind of problem would be, a chapter 6 problem would be if I pick one person. Let's say these are people's ages or whatever, right? Pick one person, what's the probability? So if I know it's normal, and I know the mean is 40 and the standard deviation is 7, and I say pick one person, what's the probability they're older than 41? How would you do that? How would you calculate that? Can you draw the picture? I've already drawn most of it. I just want you to put one little extra thing on it.
The mean.
Yeah, the mean. So go ahead and draw the picture real quick. We know it's normal. I've already drawn a little bell curve up there. And again, I've had students that just could not draw that, so I just said make a triangle. It doesn't matter. You just need some visual anchor to kind of like label. So you know this is exactly the kind of problem I would give you. We know that the average age of people in this one area is 40 with a standard deviation of 7. If I pick one person from the area, what's the probability they're older than 41? Right? If I give you that problem, you should go, oh, cool. You should go, thank whatever your favorite deity is. Thank whatever, right? God of coffee, whatever your favorite deity is, right? You should just eat that problem up. So what goes right in the middle?
40.
And then what else do I put up there?
A line, about 41.
41. So that's obviously over here somewhere. And where am I going to shade?
To the right.
Yes, so it's an arrow that points you in the direction. Greater than would be up there. I like it. Okay, maybe. And then what do you do next? So that is purely indicating everything on a picture that they told me. Everything they told me and everything they're asking me about, correct? So I'm just putting it visual, nice visual. We already know the answer is going to be less than what? Less than 50%, correct? We know it's going to be less than 50%. So what's the very next thing I do? Make a Z-score. I love it. How do you make a Z-score?
41 minus 40.
Yeah, our data point, 41 minus the mean divided by the spread. I think it's 0.14, roughly. Double check me on that, you never know. Jeff thinks he knows. anybody double checking here? Y'all all accept it? Is it 0.14? Yeah? Okay. Look at me go. So that's a z-score of 0.14. Can somebody tell me very quickly what the hell that means? What does that number actually mean? So that data point, 41, is 0.14 standard deviations away from the mean, or even better, above the mean, because it's positive. You guys with me? So if, I don't know, hypothetically, which means definitely, I ask a question just like this, what does a z-score of 2.87 mean about a data point? You would say that data point is 2.87 standard deviations above or away from the mean. I would accept either one, but more correctly, above the mean, because it's positive. You with me? Because it's very possible, 100% chance, I'm going to ask you a question exactly like that. I like it.
So it's 0.14 away from.
It's 0.14 watts? Miles? Feet? Okay. So, one thing I try to establish is when I'm talking about distance between people in a room versus distance between stars in the sky, I'm going to use different units, correct? I would not use inches to describe the nearest star, how close it is to our sun. Is everybody cool with that? I'm not going to use inches because that's going to be a silly big freaking number. You with me? And I'm not going to use miles to describe distance between two people in this room. Does that make sense? You with me? So a z-score is fundamentally a distance, which means it's got to be based on something. It's obviously not miles or inches or whatever. It's based on the number of standard deviations.
The standard deviation is like.
The unit.
Yeah, the unit.
Just like miles, just like feet, just like whatever. With me?
Yeah.
Okay.
Based on
I really want that to make sense. And that's what I meant by the standard deviation is the unit of measure we choose. So it's like the tick marks you put on a ruler, and when I put my ruler down, that's the z-score when I measure them. So this means 41 is 0.14 standard deviations away from the mean. And again, above the mean would be even better. You guys doing okay? All right. Which, again, if I, let's see. So this means 0.14 of these plus 40 equals 41. Is that cool? 0.14 standard deviations above the mean. So I don't care what numbers these are. I don't care what sigma or mu is. It could be any damn thing. Any point that is 0.14 of these above the mean will come out to be 0.14. So, let me see. Can I do this very quickly? Yes, I could. I could indeed. So let's say my standard deviation is 100. So it's really, wow. Yes? Right. And let's say the mean is 50, and I'm at 64. And I want to know the probability is above 64. What's the z-score? Can you guys, I know, on a little side note, what's the z-score for this 64? Can you change that into a z-score? Z-score would be 64 minus 50 divided by 100. It seems like Jeff's trying to make a point because he got a z-score of, holy shit. So, do you all agree this is a very different distribution than that one? I mean, that one's got a standard deviation of 7. That one's got a standard deviation of 100. Are you guys all with me? I got the exact same damn z-score, didn't I, though? So whatever area is here, it's also here. It's the same area. So every normal distribution in the universe, they will all look very different from each other. There could be some that are really skinny, there could be some really fat, and the mean could be anywhere. Mean could be negative, mean could be positive, mean could be 0. You guys sort of with me. So heights of men are normally distributed. IQ scores are normally distributed. Are those at all looking like each other? No, they are very different. Average IQ score is 100. Standard deviation is 16, if I remember, or 15, I can't remember now. Heights, 5'9". Standard deviation is 2.5. Very different. But if I change to z-scores, I can use the same damn chart to figure out the area, because every normal distribution has the same kind of idea of a shape, the same distribution of percentages. Do you have to know all that to be able to do these problems? No. But I don't know if it's been tickling anybody's brain. Why are we able to go to the same damn chart, the same blue chart every time, no matter what the thing starts off as? Because we change it all to z-scores. If I go 0.14 steps above the mean in a normal curve, I will have the same area above that, no matter what the hell the numbers are. So somebody help me out. What do you get when you look up 0.14?
5557.
Who is it?
I think it's 0.5557.
5557? Okay. Sounds like the beginning of a phone number in a movie. And then how do I get the actual answer?
99910. The 0.4.
So 1 minus this will be 0.4443. If I did this problem, exactly the same answer. Because 64 is the same relative distance away from the mean that 41 is over there. So of course it's going to have the same area above it. It's gone the same relative number of steps up from the mean, so it's going to have the same area above it. Maybe. And again, if you really don't understand the point I'm trying to make between those two, it's not going to stop you from being able to do this problem, right? But it's just one extra little layer of understanding. Okay, maybe. So, here's the point I was trying to make earlier about Chapter 7. Chapter 7 kicks in. So the central limit theorem, it kicks in when I take a sample and I ask a question about the sample mean. So if this is my problem, this is part A. And part B says we take a sample of, what do we got? 16 people. What's probably that the sample mean age is more than 41. Because the one thing Chapter 7 actually changes, nuts and bolts. There's a lot of concept. Holy shit, there's a ton of concept. And you guys have to sit there and suffer through Jeff's attempts at coming up with examples of that concept. Alternate universe floored. I'm sure there's people out there that are like, stop saying that. I don't like that. Just stop it. I'm sorry. I desperately trying to make sense of the concept. But the really funny thing to me, this is the most extreme example of a concept being this huge, amorphous, crazy thing, and it boils down to this tiny little nuts and bolts change. All that changes in Chapter 7, if I take a sample and I ask about the sample mean, the very first thing I should do is change standard deviation. How's the standard deviation change? The old one divided by square root of it. So we're going to do all the same damn work we did over there. We're going to do all the exact same work, but instead of dividing by 7, because that's the spread for individuals, I'm going to divide by whatever the hell this is, because that's the spread for groups of size 16. Why is it okay that this is less than 30? Didn't I make a big deal out of that? Is anybody out there going, this damn guy changes shit every day? No. Why is it okay that this is not greater than 30? Because what did it start off as? It's already normal, right? So I really want this to make sense. If they tell me it's already normal, I could do a problem picking one person. So of course I could do 60. I could do those kind of problems, no problem. If they don't tell me what it is at the beginning, I need the sample size to be more than 30 so that I know it's normal no matter what the hell it looked at first, right? That's the thing with 30. If they don't tell me it's normal, but I'm taking samples of the size more than 30, I know when I do the means they come out normal. So then I'm able to do shit. I would not have been able to do this problem at all if they did not tell me it was normal. We could have done none of this. Is that all right? Okay, so can somebody help me out? What does it become? So it was 7. Now I'm going to divide by the square root of 16. should come out to be 1.75. You can double check me. Every room is designed for overhead use, and I hate overheads. So now if I want to finish the problem, I'm going to do the exact same work we did over there. I'm just not going to use 7. Why? What is this standard deviation good for?
Absolutely.
No, stop. What is this standard deviation good for?
The individual.
Individuals. That's how it was constructed. It was constructed by looking at individuals. It works for problems about individuals. So of course I can't use 7 when I'm talking about groups of 16 people. So of course I have to change this. But I want you to, I don't know if you guys really get this. We talked about chapter 7 a lot. I had several freaking handouts, all these conversations. It really does just boil down to do this. If I take a sample and I ask about the sample mean, just do this. So how do I finish this problem out? Well, I do all the same work. I still want to know greater than 41. Well, technically, this would be skinnier. It doesn't really matter how you draw it. I still want to know greater than 41. I still got to make a z-score out of that, but what do I divide by now? 1.75. Let's see, that's going to be 0.56, I think. I could be talking out of my ass. Let's see. You probably are, Jeff. I don't know. I think I'm okay.
0.57.
Ah, so close. 0.57. All right. And then you would look that up, right? The whole problem is exactly the same. So if you understand how to do this problem, you automatically understand how to do this problem. They're exactly the same. The only difference is you change the standard deviation right up at the beginning. So if you look up 0.57, what do you get? Good. Oh, finish eating.
Alright, how do we know the difference between the problems? Like, just like, okay, let's say, instead of that one, you got that one. They look the same to start, what's the difference?
No, what's the difference? You guys tell me. What did I tell you are the 2 triggers for when to know to do this? In fact, they're in the formula itself. When I take A, and of course N is sample size, correct? And I ask a question about the sample mean. The formula itself tells you, oh yeah, when you're taking a sample and they ask you about the sample mean, you better use me. Here, I didn't do any of that. Pick one person, okay, so I can use that. No problem. Because that's what it was built on, it was individuals. Okay, I like it. Okay. So the one thing chapter 7 really gave us, and there's more to it, but the one thing that changes is this. It's the only thing that changes. It's crazy.
Do we
We
have
gotta-
another example of that?
Of course.
But like on this side, I guess.
Of course. Well, this is kind of, I love these rooms are like this way. It sucks. All right, so let's do one more example. Okay, so let's say I have I know the mean of something. Let's say this is, what do you got, Jeff? A lifetime batteries, certain kind of batteries, right? So you have a mean life of 483.12 days, the standard deviation of 17.96 days. Okay. So we have batteries, they have a certain amount of lifetime. I don't know what kind of batteries are, don't ask me. We take a sample of 47 batteries. What's the probability? Find the probability that lifetime of these batteries is less than, what do you got, Jeff? 46. Sorry, days. Okay, let me let you absorb that. So they give us a mean, they give us a standard deviation, we take a sample of 47 batteries. Find the probability that the average lifetime of the batteries we picked is less than 46 days. So there's a few different correct answers to this next question I want to ask you. What's a good first thing to do?
Right to everything.
Now, listen, did you say draw the picture? Okay, what picture can you draw and how do you know? And you're all like, damn it, I thought that was an easy answer because we always draw the picture, but what picture can we draw? Say again? Why normal? Where does it say it's normal? Beautiful, kick ass. I love it. She's like, dude, you wrote the problem, you know now. So nowhere in there do I say it's normal, but what saves our ass? What's true?
It's more than 30.
Yes. So since n equal to, what was it, 47 is greater than 30, central limit theorem says normal enough. Okay, let me stop for a second. So this is different from the problem we just did, because the problem we just did, I told you it was normal. That's why we were able to do it even though I just picked one person. We could then do it no matter how many people I picked, because it's already normal. This dude, I don't know what the shit it looks like. It could look like the two potatoes. It could look like whatever. I have no idea. No idea. So I need the sample size to be greater than 30 to save my ass, right? And again, if it was less than 30 in stats 1, we couldn't do shit. There's zero we could do. You guys with me? Because what's the only time I can use that Z-score chart to look at probabilities? If it's normal. So if it doesn't say, at the moment, the only thing that tells us is normal is if the sample size is big enough. Can we stop for a minute? Okay, I like it. So then we can draw, like you said, we can draw a picture. What goes in the middle? 43.12, I love it. And we're curious about, why did they say 46? Make this 460, that's better. This might be good for a couple reasons, yes, okay. But that was a little too much what I said. 46 is crazy because the average is 483, that's what. So 460, and I want to know probability less than 460, okay. Right? So it's still the same picture, we still label it the same way we would, it's just that I needed to understand why it was normal, because the sample size is big enough. All right, what's the very next thing I should do? Can I make Z-scores right now? Can I make a Z-score right now?
Yeah.
No. Why not? What do I not know yet?
Reading the same.
I don't know the standard deviation I want, yes? Do I have individuals? Is the problem asking me about an individual? No, it's asking me about the average of 47, correct? So I need to change the standard deviation. So what does it become now? So it was 17.96. What does it become now? Square root of 47.
Oh, 47.
Careful. It's always divided by square root of n. Sample size. Whatever the hell that is. I'm going to say 2.61. What is it?
62.
Holy shit. Sorry. 2.62.
2.6197.
Ooh, okay, so I'm okay with 2.62. I like it. Okay, I like it. So at this point, you guys need to be completely cool with chapter 6 problems, right? Chapter 6 problem is like the very first problem we did, where I give you a mean, I give you standard deviation, I tell you it's normal. You draw it, you put the mean, you make the z-scores, you look up the area. You guys with me? That problem right now needs to be like, yes, I can do that shit. The very next level is this. It's almost exactly the same. Once I change the standard deviation, now I just make a z-score using this, not 17.6. I use this. So what am I going to change into a z-score? What am I changing into a z-score? 460. That's my data point, right? Divided by, so you should get something kind of crazy. Negative 8.82. What does that remind me? What does that mean exactly? What's the z-score of this mean? Would you say that's very far away? Where does unusual start? 2. This sucker is 4 times as far, more than 4 times as far away as where unusual starts. You understand? So it should not be surprising that the answer is going to be stupid tiny. What's the probability something is further away than 8.82 steps down? In fact, your chart, how far does your chart go? Your chart sort of gives up after a bit.
0.59.
Yeah, it goes down to 3.5, right?
Yeah.
Negative 3.5. Are you with me? Look at the chart. And it just says, yeah. Anything less than this, just... So, if you put 0.001, I'll be okay with that. But I want you to understand why that's bullshit. At 3.5, at negative 3.5 steps, there's that much area below. Are we a little further than negative 3.5? So if you put this, I'm okay with it, because the chart I told you to use says to put that down, doesn't it? So I've got to be okay with it. But it's about 0 freaking percent. I mean, I am 8.82 steps down. You guys semi with me? So what's the probability somebody has a height that would go to a z-score of negative 8.0? An adult I'm talking about, right? Basically 0%. Maybe 1 out of 7 billion, which for most humans is 0%, right? Okay, maybe. So if you put 0.0, does everybody understand? Everybody see the 0.0001 I'm talking about? You guys see that? Because you know this is going to happen to you. You know I'm going to make this happen to you. So if you put that down, you're fine. And I won't take any points off, because that's what it says. But literally, it should be about 0%. Because we passed 3.5 up a while back, right? And real quick, why does it make sense? The further I go down from the mean, isn't that leaving less and less and less area below me? So if I go 8.82 steps below that, I've got basically nothing left outside of there, right? Within 3 steps, what percentage did we catch? Who remembers? 1 step was 68%. 95? 99.7. So there's 0.15 outside of negative 3. So how much is there outside of negative 8.0? Right? Is it exactly 0? No, but it's 0.0000002 or something crazy. And maybe. So I'm kind of happy that problem happened. Okay. All right, so you need to be cool with a chapter 6 problem, which I give you a mean, I give you standard deviation, I tell you it's normal. You just got to draw it, make the right z-score, look it up, get the right area, correct? And we've done a lot of those problems. I desperately want you to understand that all chapter 7 did was, oh yeah, sometimes you got to change standard deviation first, right? This is the only extra work chapter 7 adds. That's it. That's the only extra work chapter 7 adds. Okay, I think I made enough of a point about that, okay. Now, with all that said, I'm not trying to make you feel bad if you still have trouble with chapter 6 problems, right? We can do a few more just chapter 6 by itself. Because if you don't understand chapter 6, you ain't got a chance in chapter 7 because they're basically the same thing, right? So let's do this. Before we do any more problems, that all kind of came from one question I asked. Let's create the formula sheet, and then we'll see what kind of questions that spurs. All right, so a nice blank board. Really, I don't want anyone to lose points on the formula sheet, so you could be like, well, just don't take any points off. Well, just give me a clean formula sheet. Okay. So this is all about chapter 4, 5, 6, 7. So chapter 4 was the x, p of x stuff, right? So the very first thing we got would be this bad boy here. What was the other name for a mean? That's the name of the symbol. What's another name for mean? Beautiful. That was from before. What did we learn recently? That's another name. Expected value. You with me? And of course, I try to point out that it looks like EXP is a part of the freaking formula, which is just too much to believe. Expected value. Expected. Holy shit. That's just a coincidence, right? Math people are not that creative. Yes, sir. Standard deviation. Oh, yeah, I did. Okay. On that last quiz, the last quiz was chapter 4 and 5. It did not go as well as I'd hoped, and part of it was some of you guys were trying to use like the binomial formula for xp of x. So if I ask you, when do I use these formulas? Can anyone tell me very quickly when I would use these formulas? What would I have to give you so that you would use these formulas? I have to give you
Probability.
x's and p of x's, correct? I mean, so again, I am not a fan of teaching that way. When you see this, you use this. We've gone through all the derivation. I showed you the math behind why it works. So now I feel I can tell you what's the trigger for using these. Well, I'm going to give you x, p of x. Then you know you're going to use these, correct? And then you know I need a column of those. And what does that tell you to do with x and p of x? Multiply it, right? So then L3 would just be multiply the first two lists. I need a bunch of those before I can add them up. And then this one just says, make a bunch of x squared p of x's so I can add them up.
It's just the same, or the third column.
Huh?
That's just the next column, right?
Next, yeah,
That's the
L4.
title of the
Yeah.
next L4.
Okay. So we can do a problem like that if you want to. There's the problem on the practice test we can look at if you want to. Blah, 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 blah. Okay. So then we've got, you can put little dotted lines, by the way. That's fine. They're not words. So you can kind of compartmentalize your stuff. Then we've got binomial stuff. That was this dude here. Can anyone tell me something that's got to be true about P and Q? Give me anything about P and Q, sorry. They have to add to be 1. What else? They each individually have to be what kind of a number? Between 0 and 1. So if you find yourself putting 14.8 here, you're gonna get some weird shit. Because you're raising 14.8 to somehow, it's just gonna go crazy. It's gonna go insane. It's gonna get stupid big. These numbers are probabilities. They have to be between 0 and 1. Are you with me? So if I say 17.3% of people stare directly at the eclipse, right? Did anyone see the eclipse, by the way? No, I'm sorry. You ever make a pinhole? You put you get a big piece of cardboard, you poke a little hole in it, you get a white piece of paper, and you go out and you can see it. Get hold of a pinhole camera. It's so cool. I took a picture of it. It's neato. Anyway, sorry. There was an eclipse. I'm sorry if you missed it. 17.3% of people stared at the eclipse, right? Because I don't know, some public figure might have done it some time and maybe they thought it was okay. If I'm going to do a problem, I immediately make that 0.173. P is 0.173. Are you with me? I cannot use the whole 17.3 in the problem. Okay, maybe. Okay. And then what's the mean for this case? The best little mean formula ever. NP, and the standard deviation is going to be square root of NP cubed. Biggest mistake, people forget to do the square root, which is not a horrible big mistake, but still going to lose a point or two for that. Yes?
On the formula sheet, is it okay to put like the dots in between to indicate like multiplication? Like that just works in my brain to
Sure,
have
yeah,
it
yeah.
separated.
Yeah, that's fine. It's not a word. It's a multiplication. It's a symbol, math symbol. Beautiful. Don't get too excited. It's got to be in the formula to make sense. You can't have a bunch of math symbols off to the side that you can read none of it. Okay. By the way, I'm sorry. I've had people try creative ways to put notes on their formula sheets, and I'm like, no. That is chapter 4 right there, right? 401, 42, 43. If I remember correctly. Okay. So then we go to chapter 5. There's really nothing in chapter 5, to be honest. I believe I told you guys that I'm not going to have, don't even put the mean as a plus b over 2. I'm not going to ask you that question. You had it in the homework. You know it exists. I'm happy. So chapter 5, there's nothing to write down. But there will be chapter 5 problems. You have to know what shape it takes on. So what's a uniform curve look like? Big old freaking box. You gotta love it. So all the areas are easy, which is why I don't need a Z-score chart kind of thing, because I can just calculate the areas myself. When I get freaking curvy sides, I need some freaking help. What's the area? What's the volume of a melted crayon? I don't know. I didn't get that in geometry, right? Okay. So chapter 5, nothing. Chapter 6, we have this guy come back, right? He's huge in chapter 6. We also have this guy. These are both things we knew from before. We talked about those back in chapter 2. Sorry, I'm way over there, guys. So that's section 6.1 and 6.2. Yes?
Are we gonna have questions where it goes, like you explained it with that exact formula where it says excuse me, where you have to go backwards?
Totally. Yeah. So that would be like if I, just like the problem we did, find the 14th percentile time. So you look that up, get the Z-score, and then you plug it into the second equation there to make the raw score, right? You guys with me? So all a raw score is like heights or times or whatever the original variable was. We call it a raw score because it hasn't been processed into a Z-score yet. So it's almost like a mineral, right? Bye-bye. Okay, I like it. And then, of course, chapter 7. You can put a couple things here. Obviously, chapter 7 is this dude. Now, to be honest, I think this would confuse people more than anything, but when we do a Z-score for this, I want you to understand, what's down here? Isn't that sigma sub x bar? Right? You guys with me? And 460, that was a sample mean. So I'm going to put this up here, but you don't need it. So you don't have to put it down if you want to. But technically what we're doing is taking a sample mean minus the mean divided by the new standard deviation. That's what we're doing. But these are the same stupid formula. Our data point minus the middle divided by the spread. That's what Z-score formulas always are. So if I were you, I might not even write that down, because I never wrote that down until just now. I'm trying to be complete though. Okay. All right. So let's do this. I think a really good idea would be to do the number 5 on the practice test. So I'll put it up here if you guys don't have it. All right. So again, that's the formula sheet. This is a different board. By the way, before I forget, any other formulas you think you should have? Anything you think I'm missing? And you're like, dude, I forgot about those. What are you talking about? But if there are any, let me know before the end of class. Otherwise, that's all you can have. Okay. Now, again, you could bring in all your formula sheets for anything, but why would you want your probability formulas, right, from chapter 3? They're just going to freak you out. I would just bring this. So what this one says is the mean pounds of trash generated for each house was 281.2 with a standard deviation of 34.48. Weights are normally distributed. And in this problem, I have to tell you that because the very first question I ask is if we pick one house. So if we pick one house, what's the probability that the trash generated is more than 302? So take a minute and do that problem. If you've already done the problem, because it's on the practice test, just kind of hang out for a minute.
This is what number?
5A, 1. On the practice test, so very first problem, number 5. Yep. I'm going to catch up to you a little bit. What goes right in the middle? 281.2. What else do I want to put on there? 302. And where's it going to go? Up here. That makes sense. And then shade in the area you want. So if you don't do all of that, and you still do the work right, and get the right answer, I'm going to leave you alone. If you get the wrong answer, you're going to lose more points because I have nothing to go on. If you show me some work, I have something to go on. I can see where you went wrong. If you don't show me any work, I have to assume the worst. Does it make sense? And the picture should help you. It's a visual of what's going on. So where do I shade? Yeah, greater. So up here, so I know it's going to be a relatively small, or at least smaller than 50%. Okay, so keep going. So make sure everybody got off on the right foot. Anybody come in not get their quiz back yet? Okay. By the way, how do I know, even before I calculate a z-score, how do I know it's going to be positive? This is above the mean, right? So there's a lot of little checks and balances. People sometimes will get these flipped around. Before you even do this, you should know it's going to be a positive z-score, so it's a quick, if you get a negative, you know you did something wrong. So the most common thing is you guys flip these two around, right? So 11, so 0.63. Let's see, 603? That's close. 60? Okay. You guys get that? 0.60? Remind me, what does that mean? You're like, come on. What about it? Yes? So 302 is 0.6 standard deviations away from or above the mean. I would accept either one, right? They're both technically right. So, okay, I like it. So if I do go up that far from any mean and any normal curve, what area do I have below me? How do you find that? How do you find the area? Z-score chart. So what do you guys get when you do that?
Oh, okay. Yeah.
7257? And again, your visual tells you you're not done yet, right? So the people that don't draw the picture are the ones that tell me this is the answer. But we know better. We're not done yet. Yeah, 1 minus that. So 2, 7, 4, 3. So what does that mean?
The exact.
What does that answer mean? Because you know I'm going to ask you this on the test. What does 0.2743 mean? What's that mean? You're all like, it's a number, dude. That's what you're all about, man. What's 0.2743 mean? Well, what was the question? Start there, because it's the answer to the question, correct? So what was the question? The probability that a house generates more than 302 pounds track? Yes.
I had a question. So, what? Instead of putting 0.60, if you put 0.603, you get a different Z-score. So what?
But the chart only goes out to 2 decimal places, so it doesn't matter.
Oh, okay,
Yeah.
okay, got you.
And by the way, real quick. By the way, some of you guys got back your chapter 4 homework and you're using binomial CDF and PDF. That's how you check your work. That's not how you do your work. You with me? So if you know about normal CDF and PDF, that's great. You can check your work. That's not how you do your work. You with me? Oh, I get to be an asshole all the time. But if you do that, your calculator does well, goes on to have a nice life, and you're shaking the class again. So I need to see your work, right? So for a binomial problem, it's setting up the formula, however many times you need to. For this, it's looking it up at the Z-score chart, getting it. You kind of with me? If you use technology, you're going to get a more exact right answer, and I don't care. Because you're not in the real world yet. You're learning, and you learn better if you don't just do buttons and get numbers popping out of nowhere. Okay. All right, maybe. So tell me, I still haven't heard somebody tell me what that means. All right, good. 27.43% of houses generate more than 302 pounds of trash per whatever it was. I can't remember. Per week, dude. Is that cool? So look at. I'm not going to do all of number 1. Sorry.
Can you do the second one on A?
Sure. Real quick though. We will do A2 in a minute, but B. Do you see how B? Read through part B. Can you guys see how it relates to what we just did? Do you guys see part B? Part B says if 120 houses are selected, how many would be expected to generate a mean weight greater than 302? Okay, yeah. Tell me, so this means 27.43% of all houses generate more than 302, correct? So if I take 120 houses, how many would I expect to generate more than 302? 27.43% of them, right? So how would I do 27.43% of 120? What does of mean? times.
Times.
People used to come out of high school knowing of meant times. Not so much anymore. Right? People don't know what of means. Of means times, right? So for part B, I would just do 27.43. So 0.2743 of 120. And that's how many I would expect to generate more than 300 G pounds.
All aligned with that.
Now again, before we do part 2 of subpart 2 of part A, look at part D. First question, doesn't that look a lot like what we just did? What's the difference in part D?
Average sample.
Two things, right?
Any other
I
sample?
took a sample and I'm asking about the sample mean. So of course, what would change?
The
Standard
standard.
deviation. So I do all the same work here. Instead of this though, I would use whatever the new standard deviation is. Does that make sense? This standard deviation is for individual houses. So that's why I worked for this problem, because I picked one individual house. I want to compare it to all the other individual houses. That problem, I have to compare one group of 33 versus all other groups of 33. I need to know how spread out those are. So in part D, has everybody got all the formulas? Okay. This is no longer the formula sheet. Don't get outside. Part D, I would first figure out the new standard deviation. And again, why? Because we took a sample, and the question is asking about the sample mean. Anytime that happens, you change the standard deviation. You can't use the one that works for individuals. You want to use the one that works for groups. I'm going to hammer this home a little bit. When I drew this picture, what the hell does that mean? Like there, that little dot. What is that? You guys are like, I don't know, dude. You're the one who put it there. How did I generate that picture? I could have went around and said, hey, how much weight do you make in a week or whatever, right? You guys with me? Or it could have just been hanging outside people's houses weighing their trash the whole week because, you know, I don't have a life. I'm just weighing people's trash. What are you doing? Just weighing. Okay, sorry. This would be one house that generated less than the average amount, right? This is somebody who generated even less. This is somebody who generated like a crazy amount. So this picture you draw, you're drawing all the individual houses and how they're distributed. That's what that picture is. So we're just saying the little dot that represents our little house, what's the probability it shows up here? That's the question, right? Guess, am I with me? So when I ask a question like part D, now I've got to compare a group of 33 houses versus all the other groups of 33. And if I take a group of 33 houses, it's less likely for their average to be extreme. It's much more likely that it's going to average out. And then get some high, some low, should be closer to the real average. Maybe. So if I pick one person in here, let's say the average age in here is 22. If I pick one person and they're 27, does that freak you out? No. If I pick 10 people at random and their average age is 27, that's a little bit freakier. You would expect it to be close to the actual average. Does that make sense? That's what I keep saying about if you go out and you pick one person at random and they're 7 foot tall, you go, oh, wow. If you pick 10 people at random and the average height is 7 foot tall, you're like, what is going on? Everybody stop. What's happening right now? Correct? Okay. So that just means it's less light. The whole thing gets skinnier. Everything goes towards the average. So in part D, I'm going to have to change the standard deviation for a group of 33 houses now, right? So this is, if you let it be, it's almost too nice to believe, because that's the only difference in the work. All this work we did is going to be exactly the same. The only difference is I'm not going to use that number there. I'm going to use the new one, right? Okay, maybe. If only there was an easy way for me to know when to do that. Oh yeah, shit. So take a sample, ask about the sample mean. Maybe. All right. So I sort of asked that question for you, but let's open it up to whatever you guys have. Yeah, anything. It could be from quizzes. The last quiz. When is the corrections for the quiz you just got back? When are they due? Wednesday. I love it. Yeah, go ahead.
The ones that are inequalities, like the problem, like 2 on.
Oh yeah, I'm
five,
sorry. You asked about.
And then 2
yeah.
also on B, number 5.
So let's look at part 2. Can you guys draw me a picture real quick for part 2? 5A2. My tests are like legal documents. Sorry.
Subsection 2.
Party in the first part. See you?
Just going to the bathroom.
Oh, okay. Sorry. I think you're all packed up. So what else do I put up here?
277.
Yeah, 274, so it's got to be over here. 292. So just be thoughtful when you put stuff on there. It's an actual number line, so they've got to go in the relatively right places. I don't know the scale, so it doesn't really matter as long as they're on the correct sides of each other, right? And of course, I would shade it what? In the middle. So there's a lot of mistakes people make. Very often what somebody will do is they'll do this. This is wrong. Do not write this. Do not copy this. Do not even look at it for too long. All right. What mistake did I make? Nothing. Yeah, there's no mean in there. Z-score is always based on the mean. So I understand it might be confusing if somebody hasn't done enough of these practice problems, but we did quite a few. The Z-score has no place for 2 data values, not yet anyway, but it's always a data point minus the mean. So I've got to do the Z-score twice. I've got to change each one into a Z-score, right? So I'll have that and I'll have this. Oh, what's that going to be, smart boy? I don't know. 0.21 for the first one.
You're right.
What is it?
You're right.
No way. All right. And hold on.
Negative.
Negative, thank you. And then, well, that's going to be roughly 0.33, but it's going to be less. So 0.31 or 2, I don't know. What is it? 0.31. Okay. That is my one skill, so I like to use it sometimes. Is everybody with me so far? So we've done enough of these problems. If I have more than one data value I'm curious about, each one has to become a z-score. So now do I just subtract these? Hell no. Because these are where things are. If I subtract them, I am somewhere else, correct? And by the way, one of the worst things I see people do is they don't write what they're doing, and then they do 31%. Yay, next problem. Is that a percentage? No, it's a z-score, right? Okay, so always tell yourself what the hell it is you're doing. Especially with these, because z-scores look like areas, and that sucks. So now what do I do? Yeah, look each of these up, and we've talked about this enough that you know you have to subtract those areas, right, to get the area in the middle. It's a beautifully physical idea. One goes too far, it's just subtract the other one off, and you end up with the area in the middle. So what do you get when you look up negative 0.221? Has anybody done that?
Yeah.
Z-score chart
Point
somewhere.
4168.
416 8. Okay. And what about 0.31?
Oh, 6217.
6217? And by the way, everybody else, just make sure you can find those numbers. Double check them. Our eyeballs could kind of twitch and we're looking at the wrong line. That's easy as hell to do, right? So how do I get the answer? There's only one answer. There's only one question, right? So how do I get the answer? Yeah, that's too big. How much too big? Exactly that much too big. And then whatever the hell that is. .2049? Okay. That would have been embarrassing. Where I get it wrong is subtracting. Good job, Jeff. Yes.
Yeah, before you were saying that if you get a negative, something's wrong. Why is that negative okay?
When did in what context did I say negative is wrong?
It was,
To be honest, I don't even remember saying that. But I mean, if you get a negative area, that's obviously wrong. Area can't be negative, correct? What's a z-score being negative mean? It has a physical meaning. It just means it is below the mean. So z-score being negative. In fact, don't we have a whole positive and negative side of the z-score chart?
yeah.
Cool. So they have to be able to be negative, of course. I don't remember saying this, but yeah, areas can't be negative, right? So sometimes people will subtract these the wrong way and get a negative answer and then circle it. And I'm like, okay, area can't be negative and probability can't be negative, right? The probability that I get hit by a meteor is negative 10%. What does that mean? Is that cool? Okay, okay. I like it. So now we could do an example of anything you want. Well, contained to what's going to be on the next test. Let's be careful. Yes?
So what exactly would the 0.2
Yeah, good. What would that mean? And you're like, I asked you, man. 20.5% of groups. Wait, what was this one? Oh, I'm sorry. We're back on this one. Of houses would generate between 274 and 292 pounds of trash a week. Right? Is that cool? So, very soon in this class, I'm going to utter the words, now plagiarize, because we're going to be testing claims, so our answer is always going to reference the claim. So I always tell students, just go back to the claim and then write exactly what we think that the claim, blah, 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 is wrong or whatever. So you just plagiarize, right? So here, it's almost the same idea. How do I interpret this is I go back and I look at the question and I look at the setup. So that is the probability that a house is between this, or better, the percentage of houses that generate between these two, right? I would accept either one, but the second one is a little more true to life. Yeah.
So for D number 2, would it be the same? You just switch the standard deviation.
Yeah, on D2,
Yeah.
that's where I took a sample, so I would have to use, I erased it, the new standard deviation here. So I get 2 different z-scores, but all the work would be the same.
Yeah.
Yeah.
I'm so confused on the percentiles coming into play with these. Like, for C, like the lowest weight that would place the house in the top 5%, or like,
Oh,
when
yeah.
you're asking about percentiles
Beautiful.
in regards to these.
So guys, 5C. The lowest weight that would place a house in the top 5%. Don't say anything. Can you draw the picture? This is a normal curve, right? And I want to know the top 5%. So can you draw that picture? Every time I draw it, it's different. Go on. Where's the top 5%? Where would that be? Obviously up here, right? if I do this, what have I done wrong? I'm about to make a mistake. Don't write this. I have made a mistake. I've made such a mistake. That's a z-score then. Is it a z-score?
No.
0.05, is that a z-score? No, it's a percentage. 0.05 is in there, right? So I want to know a weight that would put somebody up there. So I can't go directly to weight. I can go from percentage to z-score though, right? But what does the chart understand? Areas that are where? The chart only understands areas that are below a given z-score. So what area is below the one we want? 0.95. So whatever the z-score is, does this make sense? Whatever this is, if it's got 5% above it, it's got to have 95% below it. Sound like Porky Pig or something. Me. 5% above it, it's got to have 95% below it. So both of these are talking about the same damn z-score. I'm going to use this number because that's what the chart understands. You don't look up 0.95. No, right? Because it's not a z-score. You look in the middle. What's the closest you can get to 0.95? It's going to be one of those special ones.
1.645.
Kick ass. Right, it's one of those little asterisk dudes because it's right in between two. I like that. So is that a weight? If a house generates 1.645 pounds of trash, it's in the top 5%. Does that make sense? That is a z-score, correct? How do I change it back into a weight? What does this formula do? It takes a raw score and it changes it into a z-score. So I want the opposite to happen, correct? And we have the opposite formula, don't we? What is the opposite formula? And this is the z-score definition formula, by the way. So do we know the mean? Check. Do we know the z-score? Check. Do we know the standard deviation? Checks. Plug and check. Plug and check. Is that right, guys? Okay. So I desperately, on this problem, I gave you X scores, correct? I gave you X's, you made it into Z scores, and then you looked up the percentage. This problem, I gave you a percentage. We did everything in reverse. We looked up the percentage, found the Z score, and then we changed it back into an X, right? So they're just complete opposite. And then, of course, math can go both ways, almost always, so be jealous. Okay. Is that better for the, so I could ask that question in a few different ways. I could have said, figure out what weight puts a house in the 95th percentile. Do you guys see how that would have been the exact same word? Because that would be the 95th percentile. So I can ask that question in a few different ways. I like it. Okay. What else you guys want to look at? You guys looking at your quiz at all? I mean, another thing you could be doing right now if you don't really have any questions is trying to make corrections in the quiz. And as you do that, you can ask me questions about the problems. Yes? Oh, let's see. Oh, yeah, okay. I love it. So 6B. By the way, nobody say anything. Just look at number 6. If you've already done this problem, just kind of keep this to yourself. If you read through that problem, can you tell what kind of situation we're in? Which freaking formula am I going to use? Am I going to draw a bell curve? Am I going to do XP of X? What am I going to do? What kind of problem is this? So now you can talk. Huh? Sort of. It does, sort of, but is this uniform? Is this normal? It's probably the one I left out. Yeah. What screams that this is binomial to me is they give me a percentage. 88% do something, correct? That automatically means that a certain percentage don't, right? So what are those two ideas? What variables do we use for those two ideas? A percentage that do and a percentage that don't. P and Q. So I can see a P, and then that means there's a Q, and I can see an N. 24. And then they ask me questions about what's probably get a certain number of successes. So that's screaming to me that's binomial. So number 6 is I call it an NPQ problem because I can identify NP and Q immediately, right? What is N? 24. What's P? 0.88. Q? 0.20. Now the question was about part B. Why would it really, really suck to do part B directly? What do I mean by that? I mean do the exact work that the question wants you to do. What does the question want you to do? Less than 22, correct? What's less than 22? What's less than 22? 21? 20? 19? All the way down to 0. You have to do the formula that many times. Do you want to do that? No. I know some of you guys want to do binomial PDF or something, but it's nah. So what's the opposite of less than 22? Say it one more time. Almost. Almost. Let me ask you this way. Couldn't it be 0 through 24? Less than 22, what does that leave out? It leaves out more than that. Does it include 22? Less than 22, does that include 22? No. So the opposite would include 22, 23, 24. So how many formulas do you have to show me? 3. For 22, 23, 24, you add those and then you subtract from 1. And look at part A. Part A, you already know the probability of 22. So you just have to do 2 more. Do you guys see that? So I'm never going to give you a problem where you have to do the thing more than like 5 times or something crazy. Right? Especially if you are aware of 1 minus and when to use it. If I would have said greater than 22, what's greater than 22 in this problem? 23? 24. Ain't no way in hell I want to do the opposite of that. I'm going to do that and be done. I don't have to do 1 minus shit because that question is easy. Greater than 22, there's only 2 things. I just have to do 2 formulas. Less than 22 sucks. So of course I'm going to do the opposite. The opposite has much less work, and then I just do 1 minus what I get. Does that make sense? Okay, maybe. You guys are like, you've said it so many times, and it still doesn't make any sense. Damn. All right. So then you would do, if I were you, I would do this. I'd figure out the probability 22, set up the formula. Let's do 1. What would the formula look like for this? Choose 22 times 0.88 to the 22, because I got 22 successes, so how many failures do I have? 2. Okay. Then you would do 23, 24, add those up. That's the opposite question's answer, so then I do 1 minus that. Does that make... That's how all probabilities work. If I can get the opposite probability easy, of course I'm going to do that, because then I do 1 minus. And then I got what whatever the person wanted. They got it. Maybe. Okay. So again, the most common mistake I see is people are using the wrong formula at the wrong time. So you just got to take a second and say, what situation is this? Do I have NP and Q? Do I have X and P of X? Does it say uniform? That's the only time you're ever going to make the big ass box is when I actually say that it's uniformly distributed, right? Yeah, bye-bye. I had a few too many people making a little normal curve for the uniform problem on the quiz. Okay. So if nobody's asking questions, it's completely your floor. What's up? And then I'll come over here. Do you have a follow-up on this?
No.
Okay.
Could you explain that?
See if I can't. We're all in trouble. This one here? The uniform one? Okay. So what shape will it take? What shape will the distribution be in? Uniform means big old box. I love it. Box. Okay. It's okay, John. And what's that box go from to? 2 to 8. So how tall will that box be? Is it 1/8? Is that right? 1/8? Sounds good. Oh shit, that's right. So be careful. It's not this number. It's actually dependent on how wide it is, right? This is 6 wide, so it's got to be 1/6 tall. So when I multiply, I get 1. Good so far? Now, there are a couple, okay, this problem is good. I would do this. I only did this on the practice test just to show you, and we'll do this whole thing. First few problems are relatively easy, I hope. So part B says, so part A is this. Part B says from 4.4 to 4.7. Okay, those are relatively funky numbers, but who cares? What's the area of that rectangle I just drew? Well, how wide is it? How wide is the rectangle? 0.3. And how tall is it? 1/6. 3/6 is 0.5, so 0.36 is 0.05. Or you just plug that shit in the calculator, right? So 5%. Okay, you guys all right? Okay. Part C is one of those easy questions, should be? 0. It's got no area if it's just equal to a number. It's got no width. Poor little dude. All right, now let's look at D and E. E gets really interesting. I think only I would describe it like that. D is the mean and the standard deviation, and I'm not going to have one of these on the test, but the practice test, you guys can use whatever the shit you want to. So what's the formula for the mean of a uniform distribution? Or better yet, what's the mean if it goes from 2 to 8? If it goes from 2 to 8 evenly. Bless you. What's in the middle of 2 and 8? 5. Okay. So the middle of any two numbers is the average of the two numbers, right? So I want to find the middle of any two numbers in the universe. I just add them, divide by 2. So the average of two numbers finds the middle number. Or, there's 6 apart, half of that is 3, 3 up from 2 is the middle, 5. So there's a few different ways to get it. So this will be 5. Standard deviation is this weird ass formula. 8 minus 2 squared over 12, right? So I think it's the square root of 3, which is something I don't have memorized, which surprises me, but I think it's 1.75 something, maybe? I feel bad that I don't have that memorized.
And we don't need that formula for the test.
So very quickly, we're going to do this because part E is very interesting, or at least, I think so. But I told you guys, I'm not going to have these problems on the test. But there's a good reason why I'm doing this. But just real quick, what's the square root of 3? Does everybody see where 3 came from? 8 minus 2 is 6 squared is 36 divided by 12 is 3. Okay. So what's the square root of 3? Square root of 3?
1.7.
Square root of 3. 1.732. Okay. Sorry, I don't know if you're saying that, but I can't hear any of you. It's crazy. This is loud ass AC. So look at part E. So now I know the standard deviation and the mean, correct? Right? Right? You guys with me? Is this normal? Is this normal? Is this normal?
No.
No, it's uniform. All right, 11. You guys are 11. You don't have to look at me or crazy. Just say no. Okay. Look at part E now. Find the probability that X bar is between those for a sample of size 43. Now, have two things just happen. Did I take a sample?
Yes.
Am I asking about the sample mean?
Yes.
Is n greater than some specific number?
Yes.
So what kind of distribution is part E using now? Normal, correct? Because n is bigger than 30. So part E now says that's nice for individuals. If I take a samples of size 43, it's now normal. What goes in the middle? 5. And I want to know from 4.4 to 4.7, correct? I want to know that area. Let me stop for a minute. Okay, so what do? Do what with these? Make them into z-scores. I've got a normal curve now, right? It doesn't matter where it came from. It is now normal. So if I make a z-score, how do I make a z-score out of this? What do I have to do first, though? Be careful. The mean was 5. The standard deviation for individual numbers is 5. 1.732. Before I can make a z-score, what do I need? So this standard deviation is good for individuals.
Change the same.
We have samples of size 43, so yeah, I need to change this. So again, it does not matter what the original distribution was. If I take samples of more than 30, it becomes normal enough. So part E will be very different from the rest of it, because all of the other questions were related to a uniform curve, yes, a uniform distribution. Part E suddenly takes that and it becomes normal when I plot all the averages. So now part E is going to feel very different because it is different. It's a normal curve now, not uniform. Whatever the hell that is, I don't know. If anybody could help out.
Like
264?
1.
1? Okay. So then I can do z is 4.4 minus 5 divided by 0.264. And you can use 264.1 if you want to. It's got to be at least 3 places, so. And then you can do the same thing with 4.7. So let me do this. This will help remind you what I said earlier. I have one side of the practice test answer key. By the end of today, I'll put the whole thing up on Canvas. I just don't know what Past Jeff did with the other side. I was excited. I was like, oh, there it is. Oh, shit. Okay. So I will post the other half of this later today. You can ask any question you want to from the practice test right now, but I just want to give this to you. but hold on.
But it's the same numbers. Oh, no, it's not.
Here,
No, they're not.
Yes.
because that's the formula.
Where did you get 12 from? I didn't.
That's the formula. I could, if somebody wanted to, you could email me and I could either send to you or I can post on Canvas the proof of that formula. Warning, it involves calculus. A lot of formulas we use involve calculus. So the 12 does come, you can actually see where it comes from, but the less you understand calculus, the less sense that's gonna make. But we did all the work to find it, and a 12 just sort of like comes out of that work, right?
Yeah, okay. I just didn't
Okay.
know where you found it from.
It's not a part of the problem, it's a part of the formula. The formula is b minus a squared divided by 12 square root of all that. That's the formula. And the formula, somebody derived it, and the 12 just comes from the work. There's nothing special about 12, it just sort of comes out in the work. I don't know what else to say. Here's a bigger thing to say. Neither of those are going to be on the test.
Thank you.
Okay. Yeah.
So do we, for number one, when you're on your, where it says for the distribution of the right, show it is valid probability distribution.
Yes.
Do you, like, can you just put where it says the sum of p of x equals 1, and that's just the answer? Or do you have to put the other, like, part of that as well after the comma?
So at this point, you guys should all realize that 1A, that kind of question, there's two answers that I need to see both of them, right? If you leave one of them off, you're going to lose points. So you have to check to make sure that all the probabilities add to 1. You have to check to make sure they're all between 0 and 1. Yeah.
This is wrong. This isn't the same number 4.
Of course it is. So, okay, that's fine. I'm going to put the entire answer key. So apparently, so yeah, number 4 is from an earlier answer key that I made. Okay. So number 4 is not the same problem. Don't worry. I want to give you what I had at least. I'll put the complete answer key up later today. Okay? So guys, listen everybody. I have a feeling some of you guys didn't hear what just happened. Look at number 4 in the key I gave you. It's a different problem because it was from an earlier iteration of the practice test. So I will put up the complete, both sides, answer key up on Canvas later today. I like it. What else do you want to talk about? Now, if you're ready for the test, you could head out. I got a few of you guys looking at me like, stop talking. Any damn time you want to. This is college. You don't even have to be here. So I appreciate that you are here. That's a smart thing to be here. But any other questions or concerns? Yes? Sure. What about it?
Just mostly the box chart part.
The which one?
Box chart, general.
The table?
Yeah, the table.
Okay. Oh, I did bring calculators. All right. Let me do it up here. Let's see. You do not have to, if you don't want to, put this whole thing in the lists, but I highly recommend you do. Because there's really simple mistakes people are making when they're doing this entirely by hand. Okay. All right. So if I go to Stat Edit, so in List 1, I'm going to put all my X's. List 2, I'm going to put all my P of X's. All right. And by the way, the first question, and this question, I'm not sure why I put that in the middle of everything. The first question, you know I'm going to ask you to show me that it's valid. So you just have to check those two things. This kind of question, I still get people confused. These numbers here, these numbers, they do not mean a damn thing. When I add them together, I get the mean. Individually, they mean nothing. Where are the probabilities in this chart? Which column are the probabilities in? X is the values. Where are the probabilities? P of X. I love it. So when I ask you, like if I said what's probably that I get 11? What's probably that I get 11? 19.2%, right? No work to do, just asking you how to read it. So here I'm asking you what's probably that X is greater than 2. The shortcut is just do 1 minus this. If they all add to 1, and I want to know what's greater than this, well, these all have to be 1 minus 0.251. That's what I did here, right? Or if you just add these up, of course, you'll get 749 also. Is everybody with me? So those questions should be really straightforward. And you know I'm going to ask them, and you just have to do that work. And you know I'm going to ask this question. So I got my X, P of X column. How did I create this in the calculator? Let's see. How do I create that third column in here? Yeah, go to L3 and make it L1 times L2, right? X's are in L1, P of X's are in L2, so X times P of X would be L1 times L2. Is that cool? Shebang. So there's those numbers. How do I, sorry, you can make whatever sound effect you want. How do I get these numbers? Yeah, go over to L, oh, what happened? Let me set up my poor little calculator. Somebody did weird shit to my calculator. All right. By the way, do you see real quick, I don't know if you guys noticed, I didn't have an L4 or an L5, so I just went to Stat, Setup Editor. But, you know, on the test, if you're ever staring at some weird thing on your calculator, I don't know what you are, just come up and show it to me. Don't, at the end, I love when people, I don't love this. They come up, they give it to me and say, I had weird stuff in my calculator, I wasn't able to do 5 of the questions. I'm like, what the hell? Just come up and show me. Just show me, right? Don't sit there and go, well, guess that's how it goes for me. No, just come show me. So L4, I want to make it, yeah, L1 times L3, so I get X squared. Is that cool? So I do L1 times L3. Right, get the same numbers. Now, real quick, not to confuse anybody, but do you understand, if I do L1 squared, did I do a square? Yes. Times L2, isn't that also going to be X squared P of X? L1 squared times L2, that's X squared P of X, right? And look how the numbers stay exactly the same because the calculator's like, whatever, human, right? Both of them end up the same thing. Are you guys with me? So I don't care which way you go, you're going to get the right numbers, okay? Now, why did I do all this calculation? Why? Oh, I'm sorry, what's up?
You said the third one is get you the mean, right?
Total. Sum of X, P of X is the mean, right? Expected value. So the mean is the sum of X, P of X, which is 5.91. 5. How do I make the calculator sum those up for me? All right, quit. So go to where? Not math. So you can go to Stat. Now let's see, which way did I show? I told you list. I was going to do it the way I do it. Go to Math, right? Go to second Stat to go to List, because I want to do something to some lists, correct? I'm going to do some math to some lists. I want to sum up a list. So I hit number 5, and I can sum up L3. And the beautiful thing is, once you've got it up there, you can just go back and hit L4. So you don't have to go all the way through those menus again, right? You can hit second enter and pull the last thing up and just replace what it is you want now. And that's where I got 5.91, and that's where I got 45.924 from. You guys with me? Okay, I like it. Okay. Okay. Is that all right? And of course, you know I'm going to ask you this kind of question, so you just put the mean in the middle, go up and down. So I get just a little over half the data is within one step of the mean. Yes?
I'm confused how you got column 3 on the calculator, because -1 times...
Which, I'm sorry, oh, column 3?
Yeah, because -1 times 2.2...
Oh shit, are these different too?
Yes.
Damn it.
Yeah.
All right, everybody. I need you to understand something. I had a horrific morning, so I am sorry.
I just thought my calculator
No,
was
you're fine.
broken.
You're
I
fine.
was like, I'm so confused.
this is more different than I thought it was. Do you guys see how these numbers are different from what you have in your actual practice test? Okay, it's okay. It's my fault. So like I said, I should not even have brought these. I just wanted to bring something, and I'd like, okay, I got this at least. So do me a favor. Make your favorite paper airplane out of this or something. I will put up, like I said, on Canvas, I will put up the complete answer key later today. I like it. Okay. Yes.
So for A, how do you check your spellings?
Say again. How what?
How do you check your spellings?
Check the.
Check if it's valid.
Oh, check if it's valid.
No, A, 1A.
1A. Okay. Okay. Not sure how many times to say this, but for a probability distribution to be valid, all the probabilities have to add to be 1. We know this. If it doesn't add to be 1, I left something out. Right? It's got to be 100% for if it's the whole thing. And each probability has to be between. What's the lowest the probability to be? 0. It's the highest probability to be. 100% or 1 as a decimal, right? So they have to add to be 1, and they have to be between 0 and 1. Yes.
I'm not really behind. I'm stuck and I'm going to tutoring to get help. I know I'm not going to be able to turn in like all the chapters that I have left before this year.
Oh, all right. That's not the worst thing in the world. You need to change your mindset from do every problem Jeff assigned to do enough out of every section so I've got practice, right?
I just wanted to run that by you.
Yeah. So you can turn in whatever it is you do. You turn on Wednesday, and then I'll just tell you to finish it, And of course you're going to finish it at some point. Yeah. Okay?
Thank you.
You're welcome. Okay. Yes.
Yeah, copy of the practice quiz.